Alright, this is the introduction to the projectile motion lab. This is the only lab where we don't actually physically need to make a measurement. All we're going to do is we're going to use a computer with Logger Pro to take a look at someone launching a projectile and make sure you bring your fully functional brain. Now, you should do this ahead of class. You should launch yourself a projectile, so go ahead and get your physics book and chuck it across the room. Go ahead and sketch the velocity vectors just when it leaves your hands at the top of the motion and just before it hits the ground. Now you're going to roll in and you're going to open up Logger Pro just like you always do, and you're going to go to File, Open, and this time you're not going to go to Physics with Vernier, but to the Sample Movies folder. You're going to open up the file that says Basketball Shot. There are 3 files in that folder. Go with the shortest one. Then you can mess around with the size of the movie. You can enable video analysis by left-clicking a button. Actually, I don't think you even need to do that, to be honest with you. You can set the origin wherever you want. The scale, you want to set it for this 2-meter stick right here, so you're going to go ahead and click on this ruler. You're going to drag from one side to the other, perfectly horizontal by the way, and you're going to say, I know that this is 2 meters. If you forget to do this or if you mess this up, don't worry, it can be done retroactively. Then you can sync the movie to the graph. Actually, you don't even need to do this step. Now we're at the important step. We're going to start tracking some points. You're going to click on this guy, and that guy is just right here. You're going to start selecting a place on the basketball, and you're going to consistently follow that point. You may think that the middle is the easiest point to track, but it is not. My advice would be to track the top, bottom, left, or right. I should be playing a video of me doing this, and it's going to go ahead and graph the data. Then what we're going to do is we're going to go ahead and take a look at that data. We're going to start with the horizontal, so the X, and you're going to see that it looks roughly linear, and there's probably 2 linear segments. You're going to go ahead and sketch the graphs and fit a line to each segment. Make sure you write the y position versus time equation for each segment, and don't forget to include units. Go ahead and do that right down here. Then you're going to go ahead and take a look at the x velocity versus time. You're going to sketch that graph just right over here, and what you can do is you can go ahead and use the statistics button to figure out the average velocity for each segment. Go ahead and compare those to the slopes that you wrote above, and since the slope of position versus time is the average velocity, it should look pretty decent. Then what you're going to do is you're going to go ahead and take a look at the y position versus time. You should fit the appropriate curve to this graph. Now let's talk about that a little bit. I personally would fit a quadratic. Why would I do that? Well, this is the equation of motion in the y for something that is accelerating, so I would probably fit it to a quadratic, and I could even read off the a term, the b term, and the c term. Note that the a term should be negative 4.9. That is 1/2 of negative 9.8. The b term is going to be your y velocity, your initial y velocity. That's going to be important in a couple of steps. Then what you're going to do is you're going to go ahead and take a look at the y velocity versus time. So this is how you get that graph, and you're probably going to fit a straight line to that. Why do we fit a straight line to it? Well, if I were to write the equation of motion for the y velocity, it would probably look a whole awful lot like this. If I were to fit this to y is equal to mx plus b, well, this is on the y-axis, this is on the x-axis, there's a really good chance that the slope is going to be roughly negative 9.8, and the y-intercept is going to be roughly your initial y velocity. What you can do is you can go ahead and write that guy right here. You can write that guy right here. I said to pay attention to step number 4. You're going to write your initial y velocity here, and you're going to write your value for g right here. You're probably going to double that a coefficient. Since these guys are both essentially the same thing, they're just different ways of getting it, you're just going to go ahead and compare them. How consistent were they?